Hello everyone, Marco Chiappetta for HotHardware here behind the camera, and in front of me I have a huge pile of hardware. It's about time that I build myself a new rig. Dave just got an awesome custom liquid-cooled main gear rig from our trip to their HQ a couple of weeks back. And my desktop, it's on its last legs. I've had it since the Ivy Bridge days, and I honestly don't know how much longer it's going to last. It's been crashing and just acting funny for weeks. So I've got a bunch of stuff piled up here. I've made some, shall we say, interesting hardware choices. Some of you are probably going to be scratching your head wondering why I did what I did, but let me explain what I have going on here, and by the end you can decide how the system came out. Alright, so here is the foundation of this system. I decided to use the MSI MEG X399 Creation motherboard, basically because I had it on hand, and this guy's got a really beefy power solution. If I remember correctly, 19-phase power solution on this board. And because I plan to use precision boost overclocking, or PBO, with the processor, I wanted a board with plenty of power headroom. So MSI MEG X399 Creation motherboard. I'm going to pair that with 32 gigabytes of a Kingston HyperX Predator RGB DDR4 2933 RAM. Now I know this isn't the fastest RAM for Threadripper, but this kit is qualified to work perfectly on AMD's platform. 2933 is the highest clocked Threadripper official memory speed without overclocking, so I'm not going to push the memory too far. It's quad channel, it's got plenty of bandwidth. So this is going to work out great. And the processor itself, it's the big boy. It's the Ryzen Threadripper 2990WX, the 32-core workstation processor. And now I know what you're thinking, the new Threadrippers are coming. Yeah, they're going to be awesome if the rumors are all true, but they're not here yet, and I really need to build a new system. I want something powerful for video rendering and 3D rendering, and I do tons of multitasking. So this is the current big boy, so that is what's going in the system. Okay, let's look at some storage hardware next. So for my boot volume, I chose the Intel Optane SSD 905P. Why did I pick this drive? Well, Intel's Optane drives, and specifically the high performance ones like the 905P, they offer really strong low Q depth performance and really consistent performance even when under load. So it makes them a good choice for a boot volume where the OS resides, where there's going to be plenty of apps and lots of activity. And for bulk storage, I have a 2 terabyte Samsung SSD 970 EVO Plus, just to hold my media, games, bulk files, things like that. And then this box back here, some of you are probably going, what's going on? So this is a Pioneer Ultra HD Blu-ray burner, model BDR211UBK. Why on earth do I need an optical drive? Well, I have some family members that are, I don't know, shall we say less than tech savvy, that still need some things backed up, DVDs, things like that. I am an avid movie buff. I like to archive my movies, and I have a daughter that will occasionally like to burn CDs and make her own songs, things like that. So, I think I want to have this on hand. That's also going to affect my case choice too, but we'll get to that in just a bit. Alright, let's talk sound and networking for a bit. So for audio duties, I'm going to use a Sound Blaster X AE5. Now this isn't the latest add-in Sound Blaster, but this is still a killer gaming sound card. It has RGB, so I can add some bling inside the system. Also has better sound quality than most onboard audio solutions on most motherboards. And since I use external speakers, I want that good sound quality. I'll notice the difference. So I'm going to go ahead and add a Sound Blaster to the rig. And now this guy here, this is an Aquantia AQ107 10G NIC. Now I absolutely don't need a 10 gigabit NIC. I don't have a switch that properly supports those speeds, or a NAS or another system that can transfer at those speeds. But I figure let's build in some future proofing. The chips used on these NICs are also newer than most 1 gigabit NICs out there, and they have faster internal pathways. So that can sometimes lead to better ping times. Figure I have it on hand, let's put it in the rig. So how am I going to cool that 32 core processor? Well, I'm going to use this all-in-one liquid cooler from Enermax. This is the Lictech 240 OCTR4. This is an all-in-one cooling solution with a large heat plate that can actually cover the entire integrated heat spreader on the processor. It's also rated for over 500 watts, which is going to be plenty. I'm not going to do any insane overclocking. I'm just going to use PBO, and I will show you more on this cooler in just a bit. Powering this system will be an EVGA Supernova 1200 P2 power supply. Now, I can't stress enough how important a good PSU is for a build. This particular model, as the name suggests, is a 1200 watt platinum power supply. Now, PSUs are often overlooked, but man, you really should not skimp on your power supply. It's just so important in terms of stability and reliability, and they'll usually last through multiple upgrade cycles, so don't skimp. Definitely go with the good PSU. I have had great luck with EVGA over the years. They've powered test rigs and personal rigs, many systems, and I've had no trouble at all. So this big 1200 watt beast is what's going in this system. And that brings us to the case. So what I have in front of you here is the Fractal Design Define R5. And why did I choose this case? Well, I wanted something just clean and understated. I know there's tons of gorgeous, tempered glass cases out there with tons of lighting and cool features. I wanted something that isn't going to turn heads from the outside, but that can handle all of the high-end hardware I plan to put in it. This guy also has the necessary 5¼ inch bay for that optical drive. All of the intakes have filters to prevent any dust or hair from getting in. I have a little dog that sheds like crazy. I don't want her fur getting in here. And I just like the look of the rig with the front door on it. The other side does have a window. I'll show you that as well. Okay, so here's a look at the other side. There is a small window there, so you can see the motherboard and any expansion cards. It hides all of the drive bays at the front though. And if I swing up top here, now there's normally some louvers up top. I have removed them because I'm going to mount the all-in-one liquid cooler up top. And then at the front of the case, you do have a headphone and mic jacks, reset and power switch, and USB 2 and USB 3 ports. So let's get started installing hardware. Here is the MSI MEG X399 Creation motherboard. At this stage, I want to put the memory, processor, and one of the SSDs in. We're going to put the M.2 Samsung SSD in. Now, on this particular motherboard, this heatsink here has to be removed to access a couple of the M.2 slots. So I've gone ahead and removed those screws, and then this piece lifts up, and now there are some thermal pads here that are being protected. So I'm going to remove this piece of tape, so that thermal pad will make contact with the SSD, and the Samsung SSD is going to go into M.2 slot 1. There's another slot right here and another one under here, but this is slot 1, and this guy is going to screw down right there. So I'm going to do that first. As you can see, the Samsung SSD has been installed in the slot, but I can't screw this down just yet because the screw also holds the heatsink in place. So we are going to reinstall this heatsink. And I don't want to slide it around too much because that thermal pad is making contact with the SSD, and I don't want to pull it out of the slot. So that is lined up right there, and we will put in a couple of screws, hold everything in place. All right, that's one. That is 2. And now this small one goes here, assuming I can get my big maws out of the way. All right, so that is the final screw going in, and now I'm just going to remove some of these protective materials so I don't forget later, because that will definitely affect how the heatsinks work. All right, next up I'm going to install the CPU. If you haven't installed a Threadripper before, it requires loosening these 3 screws. The processors actually come with a tool for doing that. So we will loosen these 3 screws. This piece pops up, the processor slides in, and then everything gets put back down and screwed into place. All right, with the screws loosened, this piece popped right up. Now we have to lift this up. There's 2 tabs here. we lift up on this, and this piece comes up. And now this needs to be removed. This is protecting the socket. Gently do that. And then there's this protector in here as well. That's where the CPU is going to go. All right, so here is the Threadripper. If you haven't installed one before, they include these little trays here attached to the processor. We're going to slide that down right into here until it goes all the way down. Then bring this down gently. We don't want to squash any pins in that socket. And push down here. So now that is in place. We will bring this down, and if you notice, for opening, you're supposed to loosen screw number 3, then number 2, then number 1. But to close it, you want to tighten number 1 first, then number 2, then number 3. So I'm going to do that now. All right, so let's get some memory installed on this board. Threadripper requires quad channel memory for best performance. And on this particular board, we're going to start at the outermost slots and then alternate inwards. It's actually labeled right here which slots to use first, but you probably can't read that on video. All right, so processor, memory, M.2 SSD installed. At this point, I think I'm going to go ahead and install the motherboard into the case. I've gone ahead and removed the side panels from the Fractal Design case that I have on hand here, and what I've noticed is that there's only one intake fan and one exhaust fan installed from the factory, and because these two fans match, I'm going to move this one to the front, and I have a spare fan here from the stash. I'm going to stick this one in the back. So I went ahead and swapped those fans. I'm just about ready to install the motherboard. Now the standoffs for the board are not pre-installed in this case, and obviously I also have to install the custom I/O shield for the board, so I'm going to do that now. I think now I'll install the optical drive. It's super easy in this case, just a matter of pulling this tab and removing the bay cover, sliding the drive right into the bay, and then I'll install a few screws to secure the drive in place. Okay, so I've got the motherboard installed, and I've been sort of assessing where I'm going to route cables and how I'm going to install my expansion cards. I've actually uncovered a problem with the slot configuration that's going to prevent me from using one of the cards, but I'll get to that in a bit. I think now I'm going to install the cooler. Now I still have to install the fans, but this guy's going to go up top here, and I'm going to sort of shift it as far to the back of the case as I can to leave room for cables for the optical drive, which are sort of right here by the front. Okay, so the radiator and fans are mounted to the top of the chassis. It's time for me to install some thermal paste and mount the water block here. Now this guy is going to sort of snake around this way, and there's some thumb screws that hold it down on the socket. But first I have to remove this protective layer and install thermal paste. I'm not going to be a psycho about the thermal paste, but I'll show you a method that I like to use. When installing thermal paste, you want to make sure that the water block and the CPU are clean, obviously. I've already rubbed the CPU down with a little isopropyl alcohol. And you want the thinnest, smoothest layer possible of thermal paste. So I like to just use one of the bags that came with the screws here and install your paste. You know, put some paste on the chip and just sort of smooth it around until you have an even layer covering the integrated heat spreader. I need a little more here. Now, as you do this, sometimes you'll find, maybe you have some thermal paste that the oil separated a little bit. If you do this, you're sort of mixing it again, and you can get a feel for how even the application is. Now, it's not going to be perfect, but as long as you cover the heat spreader with a super thin layer that's nice and even, you are good to go. You have to remember it's going to have some contact pressure from the heat plate, and that's going to help spread it out even more. Okay, so I'm making good progress here. Optical drive is in, all-in-one liquid cooler is in and mounted, RAM is in, one of the storage drives is in, motherboard is mounted. I have a couple of the cables already routed, for the fans. I'll show you the back a little bit later. So now I think I'm going to start routing cables for the front panel connectors. I have USB 3 headers here along the front of the board, USB 2 headers on the bottom, and the HD audio connectors all the way out here on this corner. So I think obviously the HD audio connector is going to come up from here. I need to leave room for a power connector as well. I'm probably not going to have room to snake the USB 3 connector through this, so I might have to come from behind the drive cage. We'll figure that out. And the front panel headers, I'm just probably going to come up right through here. So this is one of those gotchas that come up when you're building a system. The HD audio connector, no problem. Front panel connectors and USB 2, no problem. I have a zip tie here holding everything nice and tight. The USB 3 connector, however, bit of a problem. So the way the motherboard tray is sloped and the length of this motherboard makes this connection really tight. So this cable is sort of tweaked upwards. It is fully inserted. I used a zip tie to secure it from the back so it can't jostle and move around. But this is much tighter than I would like, but there's not much else I can do at this point, so I'm gonna leave it. I think it's time to install the power supply. This particular EVGA 1200P2 is fully modular, so I'm literally just gonna put 4 screws in, drop it right at the bottom of the case, and then decide where I'm gonna start routing cables. Okay, power supply is mounted. Now I have to figure out how many cables I'm gonna need. This motherboard requires 2 EPS 12 volt connectors plus a 4-pin peripheral connector down here, the ATX power connector up top, and then when I have the cards installed, the GPU requires 2 8-pin PCI Express power cables, and the Sound Blaster actually requires another peripheral cable. So I have to make sure that I connect enough to this guy to route to everything. All right, so I got everything I needed connected to the power supply. Now I'm gonna feed everything to the back of the motherboard tray and kind of figure out where everything's gonna loop back to this side and plug into the expansion cards. Okay, I've routed all the cables behind the motherboard. It's an absolute disaster back there. I'll show you that in a minute. I think now I'm going to install some cards and figure out where the cables for the graphics card are gonna go and for the sound card. Okay, so I installed the GPU, Intel Optane card, and Sound Blaster. What you'll notice is that there was no room for the Quantia NIC because the GPU is so wide, and where the X1 slot and the M.2 slots lined up, I just simply don't have room for that card, so I went ahead and omitted it. And if you were really paying attention, you're gonna notice something else. Like a meathead, I connected the front panel audio to the motherboard, but it needed to be on the sound card, so I just unplugged it from the corner of the motherboard and routed it right to the back of the card here. Now, the peripheral connectors that I have attached to the PSU are not long enough to hit the sound card either, so I stuck in a little short extension here, and I'm gonna feed another cable through the back and get that plugged in next. Okay, so that's the front of the system with all of the cards and cables installed. It is a little cramped, but I'm not gonna complain. It's pretty clean from this side. The other side, though, is an absolute disaster, so I have to clean that up next. And that is the before shot of the back. As you can see, I just sort of stuck everything through the holes, and now I'm gonna spend a little time on each cable and clean all that up. And here is the after shot. It is not the neatest cabling job, but there's just too many cables and not enough space to hide everything, but everything is connected and tied down. So I think it's time to fire the system up and see if everything works. Got the machine powered up, and you're going to notice a problem here. So the fans are running for the Enermax cooler, but the water pump is actually broken. So I'm going to shut things down because I do not want to kill this processor. As you can see, the rest of the system's powered up. I do have it posting. I'm just taking this short video to show you the problem. Not every build can go smoothly. I've run into a few snags with this one. So time to shut down and get that cooler swapped out. So here's what it's supposed to look like when the water pump is working. As you can see, the Enermax logo's lit up. Now, I had to replace the previous cooler with a 280 millimeter model. If you recall, the first one that failed was 240 millimeter, so it forced me to drop my optical drive down one bay, and the 140 millimeter fan I had placed here, I had to replace with a 120 millimeter fan. But other than that, all seems to be working well here. Now, it is a little tight. This is actually just barely touching the optical drive. It's Very, very little pressure. I'm not worried about it damaging the tubing or anything. And luckily down here it is not touching any of these cables or the back of the GPU. Now the next step will be to install Windows, get all of the firmwares, BIOS, everything updated, and then get some control software installed so I can make some of these colors match. Alright, I've been running a few tests on the system, and what you see here is Cinebench R20 alongside AMD's Ryzen Master software. I wanted to get a sense of performance and to see what CPU temperatures look like. And I've already run Cinebench quite a few times. The system is right off to the side here. Please don't mind my messy desk. But what you'll see is idling at the desktop, even after quite a few Cinebench runs, the processor is running at right about 43.2 C, and I'm gonna go ahead and run Cinebench again. It's actually really fun to see 32 threads ripping through this benchmark. So there we go, CPU is at 100% load. CPU temperature has hit, I don't know, 56.5. Now I've run this quite a few times and I have seen temperatures get it to about 61, but you know, even after 10 consecutive runs it doesn't get much higher than that. The CPU cooler is working really well. Let's see what we get for a score here. We're just about done. So 11,361. Let's start it again and I'll try to zoom in on the temperature so you can see what it's doing. Alright, just started it up again. Let's try to get in a little closer. I'm not sure how well you can see it on video, but we're at about, what, 57.5 right now, 57.6. I think you get the idea. Although I'm a little leery sticking with the Enermax cooler after what happened with the first one, I really cannot complain about this level of performance, so we're gonna ride this out and see how she behaves over the next few months. I'm sure some of you are curious what storage performance looks like. I ran a couple of Crystal Disk Mark tests on the system. This is the Optane 905P's performance while it is functioning as the boot drive. The benchmark was run from this drive and Windows is on this drive as well while this test was being run. As you can see, sequential transfers, not crazy. They're never super high on these drives compared to some of the faster NVMe NAND SSDs, but look at that 4K Q1T1 result, 176.2 and 158.1. If I jump over to the result for the Samsung SSD, you can see how much lower that 4K read is, but bang, that 3.5 gig per second sequential sure does look good. And here's some quick GPU performance. I have the Power Color Red Devil RX 5700 XT. It's running at stock speeds, but it is in OC mode. This particular card has a switch to switch between OC and silent mode. And this is Firestrike Ultra running at 4K right now, pulling about, at this point, I don't know, 30 plus frames per second. And we'll go ahead and show you the final score when it finishes. Here's game test 2 for just a moment as well, just to give you a few more visuals, something to check out. And there you go, that's the final result, 6362. GT1 showed 33.49 FPS, GT2 showed 24.25 FPS, and the graphics score was 6470. I wanted to quickly talk power for a moment as well. If you recall, I have an EVGA Supernova 1200 P2 power supply in this build, and right now I'm running the Furmark CPU burner, hitting all 32 threads of the processor, and I'm not sure how good this is going to look on video, but back there is a power meter that's checking power coming from the outlet, and the system is pulling about 388 watts, so plenty of headroom left when the CPU is under load. I'm not quite in the sweet spot in terms of efficiency, but lots of headroom there for the CPU. Now I'm going to hit the GPU. Okay, so here's the GPU stress test running. Let's see what kind of power we're pulling from the wall now. So a little bit higher. System is pulling, let's see, 432 watts right now. And what happens if you whack the CPU and GPU at the same time? Well, let's find out. System is pulling over 600 watts. I've seen it peak around 640, but still plenty of headroom for this setup. All right, and there she is. She's finally done. That is the completed system in the case with the side panel on and the window exposed. I think it looks great, nice and understated, but there are some things with the system that I am going to tweak over time. Let me give you a quick look at those. I know this one's kind of silly, but I'm not digging the white slot bay covers that came with the case. I'm going to swap those out for some black ones. I just think the white detracts from the look of the back of the system. And these open mesh sections. So right here, there's another one above this fan right here as well. And there's another one on the top of the chassis that I'll show you. So if you don't have positive air pressure from your intake fans, any open section like that is just an invitation for dust to get sucked into the system. So I have some magnetic dust covers on order that I'll cut to fit. And here's a quick look at the top of the chassis. So I put one of the modu vents, as they're called, to cover up this section. But so here is the radiator for the liquid cooler, and this whole section is wide open. So dust is really just gonna get sucked in there. I'll cut a piece of dust cover to cover that section as well. And here's a quick look at the front of the system for those that are curious what it looks like. There's door closed, there's door open, so just the optical drive there at the top, and you can see the dust cover and the intake fans there as well. And that about wraps things up. I hope you dug what you've seen here. The build did not go exactly to plan, and it wasn't always smooth, but I think it came out great. The chassis is understated on the outside, but it's an absolute beast on the inside. I'm definitely going to have fun using this system for the next few years. So once again, this is Marco Chiappetta for Hot Hardware. If you like what you've seen here, please like and subscribe, and don't forget to tick that reminder bell. Thanks for stopping by. Well, that certainly doesn't sound right.